This tutorial is to show how to analyze beam using fppSuite. Before we go on with the tutorial, if you want to send us a message, you can type in your message here by clicking the button at the bottom corner and send it to us. We'll be glad to respond. This is the beam tool, and this on the left side is the section studio. The section studio is used to define sections which are thereafter used by the beam tool. On the beam tool, we have the geometry tab. The geometry tab has span, where we define the span of the beam, and it has section, where we load the section that has already been defined by the section studio. Then we have the support. This is where we define the support for our beam model. Then we have the loads. Here we can define whether the UDL load or a point load for our beam. Then we have the material. Here we can check whether to include shear deformation or not. We can also set the material modulus of elasticity and Poisson ratio, either through the custom tab or using the presets tab. The preset tab, just to choose whether concrete or steel. Let's go back to the geometry tab so we can start defining our beam. We are going to analyze a 3-span beam, so let's add the 3-span. The first span is going to be a 6 meter. The second span is going to be 4 meters, while the third span is going to be 6 meters. Let's load our section. Our section is a rectangular 225 by 450 beam. Then we go to the support. In this tutorial, we're going to make our support to be pinned all through. So it's a continuous beam. It's going to be pinned all through. Then we go to our load tabs. Here we define our load. We're going to choose point load in this tutorial. For the first span, the magnitude of our load is going to be 400 kilonewton. And the position is going to be span of the first span, that's 3 meters. Then we add another point load. We choose the second span. We enter the magnitude of the load, that's 150 kilonewton. Then the position is going to be mid-span, that's 2 meters. We should note that the position of the load is always relative to the span under consideration. If it were to be the whole span, that would have been 8 meters, but the second span is 4 meters. Then we move to the third span. Our load is 200 kilonewton in magnitude, and the position is mid-span, which is 3 meters. Then we go to the material. We are not going to include shear deformation here. We are going to set preset. Then we choose concrete as our material. Then we run analysis. These are our shear force diagram, our bending moment diagram, and also our deflection diagram.